My name is Sebastian, and recently I saw a tweet which was sent to me from a close friend of mine, which detailed the uh, latest cheat code and quote unquote the final secret of NieR Automata, which is a game that I like quite a lot. My friend, of course, knowing that I like to reverse engineer games, sent it to me and showed it to me. Now, I've never tried to reverse engineer NieR Automata before, so I actually wanted to take a crack at it myself after seeing Lance McDonald find this final cheat code. So I am not sure how much experience Lance has, but of course he very clearly loves the game very much. So I thought I would take a crack at it. And to activate the cheat code, he basically stood between two barrels. I should put the video up on screen now. He stood between two barrels and entered a sequence of keys, which the game recognized, and then sent him directly to a title card. So to find this, my first thought was to actually, well, it's cheat code, so I look up cheat string references. Nope, nothing there. Maybe hack. We get quite a lot, but I didn't see much interesting here. So my next thought was, why don't we track down how the endings are executed? So we look up ending, and here we have a list of all the endings in the game. So just as reference, I went to the ending wiki page for NieR Automata and found ending K, which is what happens when you eat a fish in NieR Automata. So I opened up ending K. Let's go to string references. And we see here we have two references, both just showing pointer position to it using the LEA instruction. So just glancing at it, we see a list of endings here and one of the references. Going to the other one, we see here, I've named this function load scene just from a slight analysis from before. We see we have ending K, we have a string called fish16 up here. And then we have BGM player die and another call to a function down here and another call directly after that. So after I started recording this video, I kind of realized that I kind of start rambling on about nonsense when I start diving into some of the deeper code. So you're probably going to see quite a lot of cuts in this video just because I cut out about 30 minutes of me going into a function and how it works. But I'm still going to try to get to the point on how the actual cheat code of the game works internally. Thank you. Looking back here, I cannot tell what this does yet, but what I do know is that load scene seems to be very important. So here's what I would do. I'll open up the game and I will open up cheat engine as well. And we'll find load scene here. And we'll place a breakpoint on it using F5. And then, let's see. We can go to system and we'll do return to title screen like that. So if our theory is correct, then load scene should be called right here. And it is. So we can take a look at the arguments real quick. So load scene has RCX, it has RDX, and then R8, and then R9. Yeah, there we go. So RCX pointer, we open up reclass, attach the process, and we check it out. So it's just -1 all the way across. And I can assume that this structure is about OXC size. So 3-4 byte integers perhaps, or pointers. I'm not entirely sure what this data consists of. Keep in mind, I've only been reversing this game for a few hours now. Probably a little bit less than that since I got stuck on de novo a little bit. So second argument, RDX, which we believe is a constant value, which is currently F00. And then scene name is R8. So we'll pop this back into reclass to view it in memory. And we see us loading the string start, which is located in the data section. And then R9 is that same structure. So we open this up, but this address is really small, so I don't actually think that contains anything. Okay. So it has something in it, but I don't think it's very useful. So to test our hypothesis, we'll go here to ending k, and we see that it moves uh, the string ending k into R8 and then moves F30 into EDX. So if we copy ending k, we copy the address to it here, and we pop it into R8, and then we copy F30 into RDX, and then we continue. We'll let the game run again. And there we go. So this has forced ending k to be executed on the system, and it rolls the titles. So it's loading a scene again. We can assume that this is just the start again. So close that. And it will load start screen again, just like this. So now the question is, how do we load this secret ending? So, I mean, first what I do is open up load scene, and we can just start looking at everything passed to it. We see a test room, which I've tested before, nothing there. See bunker, back title fin. Okay, so what is this, right? What is back title fin, and where does it call it? So this is obviously the final call of the game. So let's go here, and we'll go to system, return to title screen. It's going to call the function again. So this time we're going to go ahead and pass, we're going to go ahead and pass the pointer to back title fin to R8 like that. And we're going to pass OXF10 to RDX. And then we'll run it, and here we go. And here you go. Here's the title card. Returns you to the main screen. Breakpoint. And there we go. Unlock chapter select, debug menu, debug room, and some new items as well. And there you go. So that's accessing the secret menu, I suppose you could call it. And just like that, pretty simple, honestly. All right, so now let's look into how it's actually called in the game, right? So if we open this up in our IDA pseudocode, we see load scene is executed once v5 equals 9, and v5 is initialized to 0, and it is incremented every single call. So v4, maybe it's best if we start at the top of this. So looking at this function, we see we have this function which I dubbed g underscore check map on position. So if we open it up, we see pseudocode fails because of de novo. So that means we're going to have to look at the overall assembly of this function. So taking one quick look at it, we see a comparison of OX100 to this address here, which we'll paste in here and see. So it's currently OXF00, right? Now, what this means, I'm not entirely sure. It could be some sort of control, but here we have this. It's a call to, or it's a reference to robot m underscore pro underscore first area, which from watching Lance's video we understand is the actual boss area of the game. So then it calls this, which taking a look at it, it's it's CRC32. So all it does is takes the string 0080 a robot m pro first area, and this is the string length. I'll comment that. So string length CRC32, and then EAX is the string, and then it puts it into here, which we can assume is the current CRC32 hash of the map that we're in. So, it compares it. Okay, so it compares the hash of this to our current map hash right here. So if it's not 0, then return 0 EAX. So return false. So of course, if we return false, then this fails. It tests it and a jump if not 0. Or it should actually just go down here and then return like that. All right, so return false. Comment this. We can also get the hash for this just by recreating the function down here. And I've rebuilt it in C++ here so you can actually execute it and see. So there's the hash, which this isn't correct, but that's fine. So we have the hash there, we check it, jump if not 0, and then we're testing this. So what this test is, I'm not entirely certain. It's all 0, 0 for me, so I can also assume that this is because I don't have a controller actually attached to my computer. I didn't play this game using a controller. So test it and then jump f0, jumps to the return false statement again, right? So we want to make sure both of these are skipped, and then move EAX, move this into EAX like this. So I'm assuming this is some sort of controller thing here, but we can actually go back and check here. No. Oh yeah, right. So going in game, I'll load up the save file currently, and we'll see. Okay, so going in, we can actually start testing some of these. So we'll open up one of these addresses like so. Still nothing. Then we're going to move into EAX. So moving into EAX is a 32-bit register, which means that's only reading the first 4 bytes here. So it's reading this right here. And we see behavior base. So yeah, this is very likely the player that is called here. So looking at player, we can see REX plus OX50 right here. So this is our position, right? So opening up the game and moving around, we can actually confirm whether this is our position or not by, for example, jumping. So it may be hard to see, but whenever we jump, our Y position goes up, we fall, Y position goes back down, like that. We move forward slightly, changes, move to the left or right, changes. So it gets our position. So this is what it's doing here. So we're going to call this G underscore encrypted player. Call this decrypt pointer. And then we're going to call this get player position. So it gets the player position, then it moves it into a temporary register on the stack. It does some testing here. So what is this? this is another floating pointer here. So we look right here, we have this. We have these three floats right here. We have negative 665 x, y, z. So the z is 473.69 and the x is negative 665.000. So looking at here, seems we have, so subtract, multiply, move, subtract, add, and then we have commas right here, 1.5. So this is just checking distance. So check dist. This is square root. So we have floating point square root right here. So this is getting the delta between them. So we have this here, move XMO into here. So get delta between the positions, and then it performs a distance check. So of course you have like x times x, 2 plus y times y2 plus z times, or z plus z times z2, yeah, and then it square roots them. And then it sets AL to the z flag, which is set by commas here. And then it returns EAX, so I'll comment this. So return true down here. Okay, so now that we've established what this does, we can go down here and we can see if test EAX not 0, then it jumps down here. And now it starts testing this. So if we go here and we look at this, we see it is dword pointer of keyword plus 4. So again, we can kind of assume this is a 4-byte action, although it's really hard to actually tell what's going on because I'm quite certain, as Lance put it in his video, this is checking for the right trigger of the mouse right here, which if it's not going, then it just says fuck this and it goes away, right? So going down here, we have Zor XMO, so it sets it to 0, moves it in here. We'll look back in here again. So what is all of this doing, really? Well, to really understand, I want to take a look at some of these pointers going on in here. So viewing pointers in memory is probably the easiest way to really understand what's happening in memory as well. So we see we just have 20 set into REX, and then it moves into here, right? So what is this 20? What could that be, right? So I don't see anything change when I go in game for it, so we start looking around, see what else there is. We see this moved into RCX, so we browse this in memory, check what it is, set this back. So we see this moved into RCX, RCX moved into RAX. So we can start looking into this. So we'll open up the pointer, expand it. We see it's accessing OX8 and OX10, which we see are both set to 0 currently in memory. So this is pretty much nothing. Array is set to 0, so it jumps down here. Then it tests RDX, and RDX and RDX are both equal as well because, well, it's not equal, I guess. Test RDX, RDX is checking for null pointer, so it's got to jump here no matter what, and then it will keep going. Following the flow of execution, it decrements this, moves RCX into here, and then we'll check this pointer. So this pointer is just one more down from it, and this one actually has OX10 set, which I'm assuming is going to be checking. So RCX is checked here, moves RDX, RCX into 10. Okay. So it seems like it's just more of initializing values here and setting it here. And then once we get down here, we see moving EBX into R9D, jump of 0. So this is again just a bad return, kind of. So I'll just isn't return false. I'll comment this return so it's a little bit easier to see. So we have return, then we have a move into our 10D right here. So if we read what this is, we'll see we have 08, 04 in here, and then actual layout into it as well. So R9, R9, what does this do? We can assume this is while 1 as well. So while 1, this is kind of assuming that we have everything set up for this, and it's going to begin a loop. So within this loop, it tests v4. Now v4 is set to 0, so it needs to be 1. So because its first iteration, it's set to 0, so it checks v3. No, v3 is set to this here. So what is this here? Let's look. So v3 is currently RCX, yeah. So we'll test where's RCX set. RCX is set right here. So opening up RCX, we see this again. And we saw this before. So here we have v3, and it's going to open up, test it for that. So if we open this up right here, and we test the first address right here, which is going to be 0, and we put in our calculator, so 0 and 8 is 0, else v4 equals 0. And then it goes down here and sets v3 equal to v3 plus ox10. So I made a mistake because v3 is actually set to, what am I at right now? It's set to D0, I believe, so it's set to this. So it goes to the next node, just like this. And then it will keep going through here, just like this. And what does it do with that? If v3 equals this, then it just returns. So that means I'm guessing a end of list, I'm kind of assuming. So anyways, let's go through this. So we need to check that result is equal to v5. So here is our actual cheat code here. Here is our list of inputs right here. We have 8, 4, 8, 2, 1, 40, 20, 80, 10. And I believe that's it. Yep, that's all 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our 9. So if this equals 9, then that means we entered it correctly. So we're basically checking that result is equal to this, and this is the correct key that we're inputting currently. That's basically what it's saying. So it's going to increment every time we enter a key, I would assume, and it's going to pass this. So if it checks it, we're good, right? So if that passes, we're good, and it goes to the next key down here, and it continues the loop. But if this is the 9th key we've entered, then that means we successfully entered the cheat code. So executes this function here. We're not entirely sure what this is. If we go here, we see time get time. So we can kind of assume that's using some sort of timestamp, which is typically used for server authentication, possibly, right? So using that, we go down here and we see it calls load scene v6 passing RCX, which is likely just empty memory, and then oxf10, backtitle fin, and at v8. So just like that, we see exactly what's required. So we can also possibly change the cheat code as well by actually modifying these values right here. And these values are very likely mapped to The I cannot say for certain if they're mapped directly to only controllers or not. It's a little bit harder for me to test, but that's how that works. So I think it's safe to say this is a node list of all the actual keys in the game, and OX0 is actually saying if it's pressed or not. So that's what I would say is very likely happening here. So down here, what happens? So why would it go down here? So there's no break in this situation here. We see it jump to just from here if it's not correct. And let's see down here. When is this jump to? D word equals 0, like this. Okay. 0.0, it's pretty simple to assume that this actual floating point right here changes. I would not doubt it at all. Although it's a little hard for me to tell right now. But I would assume this is resetting something here. But it's a little bit difficult to tell. So it should be noted as well that this is called within the actual update function of the game, meaning that this is always called. All these functions, these are called every single frame of the game. So just like this one, as long as this is set to true, or as long as it exists, I should say, like this, which it is set to 1 currently, then it will execute this. And then it will load back title fin, just like before, and just like before, you will unlock all those new items in the game. I don't really have much else to say, but thank you for watching my video, and I hope it was enlightening in some way. And if I got anything wrong in this video, for anyone who has been reversing this game for more than a few hours, then please let me know, and I'll look into it. But thanks for watching again. Appreciate it.